I'm going to go over the 1.3 quick check. First off here, we're talking about density. And remember that density is density equals mass over volume. But we look at this problem here and said, here's some information. And it says, where's the question? Use the data to identify the metal in the block. Okay, so here's the real question down here. Use the data to identify the metal in this block. Well, if I could identify it if I knew what the density was, because here's the densities down here. So if I can calculate the density, then I can just pick out which of those four is the actual correct metal. So my real question is, find the density using this information. Well, what do I know? Here I have a length and I have a width and I have a height, and I can put those together to get a volume. And there's the mass. We know about the mass, and we're looking for the density. Okay, so let's go back to our problem then. So we say density, that's what we're looking for. Okay, mass, that is 139 grams. Okay, and the volume, we've got to calculate that. Volume is length times width times height for our block. So that's going to be 3.57 centimeters times 2.83 centimeters times 1.75 centimeters, and that comes out 17.68 Okay, so 17.68, and that's going to be cubic centimeters. Centimeters times centimeters times centimeters, centimeters cubed. So here's my information, and I can see what I want here. So if I think about my density triangle, so density, mass over volume. Okay, I want my density, so therefore my equation is density equals mass over volume. And I'm going to substitute in mass 139 grams divided by 17.68 cubic centimeters, and I get 7.86 grams per cubic centimeter. And I look back at my list, and 7.86, that goes with iron. So I have done my IESA. Here's my information. Okay, here's my equation, pretty messy. Here I substituted in, and here I got my answer. But then what I really wanted to do was to answer my question, how can I identify the metal? And I can identify the metal because it's the one that has the density that I calculated, 7.86. Okay, second one is a little more straightforward. The density of gold is 19.3, so I want to know what's the mass of my metal. What's the mass of my metal? So what do I know? I know density, and I'm looking for my mass. So what I need is my volume, and I can see my volume is going to be my length times my width times my height. So this is a good place to deal with this. I get 15.489, and that's centimeters times centimeters times centimeters, so centimeters cubed. And I want to find my mass. Okay, so what's my formula? I want my mass this time. So here's my density triangle. Density equals mass over volume. I want the mass, so that's going to be density times volume. Substituted in 19.3 grams per cubic centimeter times 15.489 cubic centimeters. Those cancel out, and my answer, I get 289.9377. And since I had three significant figures for all my numbers, I'm going to call that 299 grams. That's my mass. Okay, the last part is the kind of logic questions. And we're saying here, it says comparing objects, considered a block of copper, that's density of 8.92, and a block of gold, density 19.3. Density of gold is very, very, very high. If you've ever held an actual piece of gold, like pure gold jewelry, it's very, very heavy. So which block is more compact? That was our thinking about density, which is more compact. And hopefully you come with the idea that gold is, since it has a greater density, is much more compact. So keep that in mind. So if I have two blocks of the same volume, then the mass of the copper block is what? More or less than the mass of the gold block. Well, who's more compact? The gold is more compact. So into that same volume, I would expect more gold to pack into that volume. So my gold is going to be heavier. Now the question is, what's the mass of the copper? The mass of the copper is less than the mass of the gold block. If the blocks have the same mass, then the volume of the copper block is what compared to the volume of the gold block? So again, if the copper is less dense, then if I have the same mass, then it's going to be kind of fluffier. Okay, if the copper is more dense, then it's going to take up less volume. So the volume of the copper is greater than the volume of the gold block. So which is more compact, or in this case, a little bit easier to say who is less compact. Okay, so the copper is going to be take up a smaller volume because it's less compact, and it's going to, in this case here, the copper is going to have the greater volume. I think I said that wrong. It's going to have less mass because it's less compact and greater volume. That's it.